Good afternoon. Today we're going to be talking about vectors. Vectors are quantities that we use quite often in physics. That may seem like a new term to you, but you'll find after going through this lecture that they're actually quite familiar. Today we're going to be talking about what vectors are, how we represent or draw them, and the difference between vector quantities and something called a scalar quantity. We'll also go over a few examples of what quantities count as vectors and what quantities don't. What are vectors? Well, vectors are physical quantities that have a magnitude and a direction. Now, magnitude may be a term that you're familiar with from vocabulary. In physics, it has a really specific meaning. Magnitude is just the amount and the unit for a quantity. So, for example, 5 meters. That would be the magnitude of the distance or displacement or length. Direction tells you which way the vector is pointing. So a vector quantity could point up, it could point down, it could point east or west, north or south, along the x-axis or along the y-axis, and the direction tells you which way that is. So for example, one vector quantity is velocity. I can say that my cat's velocity is 5.5 meters per second north. 5.5 meters per second is your magnitude. And north is your direction. How do we represent vectors graphically? We make a coordinate axis, and we're going to here let the y direction, the positive y direction be north, and the positive x direction be east. Now that's totally arbitrary. You can choose these axes to be something else, but this is what we're familiar with, so that's what we're going to do. I'm going to say that each block on my graph paper is 1 meter. So to represent this vector, what I want to do is draw a dot at the origin, and start the vector there, and then count over 5 blocks, and then end with an arrow. So this vector represents the displacement of a cat that is running 5 meters to the east. So we can also have this in the opposite direction. We can have a cat running 6 meters to the west. The only difference here is this is a little bit a longer displacement, and it's pointing in the opposite direction. So to represent this vector, we're just going to start at the origin and count over 6 blocks westward, and have the arrow point along the negative axis. To make things even more complicated, we can add angles to the description of the vectors and their direction. Cat's running 10 meters, 70 degrees west of north. I'm going to have to do a little bit of estimation here as far as blocks are concerned. I'm still going to have 1 block represent 1 meter, but 70 degrees west of north, what does that mean? Well, north is the positive y-axis. West of this would be in the second quadrant. So what I'm going to do is find where 70 degrees is west with respect to the positive y-axis. And that's about 70 degrees. And then I'm going to draw my vector 10 units pointing in that direction. 70 degrees west to north. 10 meters. Notice that the arrow points in the new direction. There are other types of quantities that we use in physics. These quantities that do not have direction but do have a magnitude are called scalars. You are very familiar with these if you took chemistry or biology, because some examples of these include length, volume, height, mass, and time. There's no direction with mass, and there's actually no direction with time either. There's only one, right? It always goes forward, unless you're somebody in a movie. But we're not, so time is always a positive number. So some examples of vector quantities include the following: velocity, force, acceleration, and displacement. Displacement might be a term that you haven't heard before. Displacement tells you how your position has changed from one point in time to another. Here are some of the units that you will need to know. We use the SI units. The unit for velocity is meters per second, acceleration, meters per second, or meters per second squared. Force, the unit is Newton, and displacement, the unit is the meter. Be careful though, when you're using vectors and trying to go from a vector to a scalar quantity. There are certain quantities that do have exactly the same unit as vectors, but in fact they are scalars and don't have a direction. Two examples that commonly get confusing for students in physics are distance. Distance is a scalar. It's how far you went, not the change in your position. And speed. Again, the units are going to be meters per second for speed, just like velocity. The unit is meter for distance, just like displacement, but distance is a scalar and speed is a scalar. Speed does not indicate which way you're actually going. And that's it for my introduction to vectors. Next, we'll be moving on to vector operations, how to add and subtract, and multiply vectors by scalars, and how to actually add them so that you get a good answer that will get you nice points on your physics test. Thank you for watching.